Welcome to part 3 of using Firebase Firestore database backend solution with Unity3D for game development purposes. And this is part 3. In part 1 we did a lengthy introduction, overview and comparison of Firestore with real-time database MySQL and tried to understand it and its pricing. In part 2 we did the general setup of Firebase project, our Unity project, created the JSON and plist files of Firebase settings, added Firebase SDK to Unity3D, and talked about some brief talks of the data structure, how you should plan it before even getting into Firebase or starting development of your product, and why to keep all your data structure uniform in each collection or table instead of non-uniform structure, which Firebase actually promotes as a feature. So this video we will be adding actual data to our Firestore database and we will be getting into code, and this video assumes you you are at least beginner level in C# programming, at least. I won't even call myself intermediate programmer or game developer. I am a amateur and indie myself, so my code might not be the best, follow the best principles of programming, but let's get started. So for planning my database structure for my chess game, basically I decided to go with 4 tables or collections, one to hold all the matches. These documents will be the actual matches and the fields will hold that data about the matches, win, loss, players who were all involved, etc. And logically speaking, at my planning stage, I had actually planned only for 2 tables, which were matches and users. The ratings, which is basically the ranked rating or MMR or EL or whatever player rating is after each match. I had at initial stages thought to keep ratings as a sub, as a, how do I explain it? Yeah, let's see here, as a sub field or a sub data of the user itself. But talking from scalability point of view, keeping ratings or moves as their own tables is better, because you get better performance, you get better organizing your data, better relationship between these collections and stuff, and your data is more readable and understandable. And same with matches. Earlier moves were meant to be like a subfield of match itself, but then I separated moves into its own collection table. And I will be uploading, I created the database structure and all the fields I need and stuff. I planned it all on a piece of paper in my diary with a pen. You can do it in Excel, and I will upload the screenshot of that page in my blog post, so anyone interested in checking out my database structure and how it was planned, you can just check the blog post whose link is in description. So let's go into code. This is my own project, so yours will be different. We will just I will not be sharing my own code per se. The purpose of this video is to teach you, to show you how it's done, not to give you pre-made code or to make the solution for you. So you should only follow my code as an example, as boilerplate templates, as for reference and understanding purpose only. So I have created a class, C# class, to hold all the code related to my Firebase project in a script of its own. And that's because if I ever have to replace Firestore with, say, real-time database or MySQL or anything, I will know that I only need to change all the code in this single class and not any of the other class. So I've isolated all my Firebase code in a single class. Then I have created a game object, empty game object called Firebase Manager, attached my script to Firebase Manager so that I can just use my code. And so the thing we talked about in last video was why you should be using uniform structure of data and not like you should not be leaving out these empty fields even if you're not filling them for any particular entry or anything. Just watch the last part of the last video or the blog post. So the challenge was that if you see the official Firestore documentation for Unity and its examples, they do not really explain anything there. They just show how it's done, and basically what they are doing is so let's start from initial step. What you need to do is, so what I have done is I have a start method, update method, pretty standard. Then I have a setup Firebase method, and I'm calling this from my start method after checking that we are online and I have internet connectivity. So what Firebase method setup Firebase does is uh, it creates a reference instance of the Firebase Firestore database. So first of all, you need to import the Firebase classes and just use Firebase, use firebase.firestorm, and I've also used firebase.extension somewhere, so include this and link. Maybe not link, depends on your use case. Then we are going to create where is it? Yeah, at the top. Yep, we are going to create a private property called Firebase Firestore, and this is basically the object which holds a reference to your database, to your basically to your whole project. And this object does not hold this FSDB or Firebase Firestore will not hold a reference to your collections but your whole project itself. So just like create that, and in setup DB, as you can see, we are using default instance. You can make this hold a reference to a collection itself or something else, but just go with default instance because we want a reference to the root of our database. Then same way what we have done is we have created properties for collection reference. And what collection reference does is collection reference is a reference to your particular collections or your tables in MySQL terms. And I've created properties to hold my users table, to my matches table, moves table, ratings table. And then what we do is we just instantiate them. So the way to do that is in Firebase example, it's basically it's something like this: firebase.firestore.default instance dot collection name. And so what we did was we, like, instead of writing this kind of long code again and again and remembering all of it, what we did was we created easier to remember references. So our FSDB holds this part of the code, and same way what we are doing is we are holding a reference to each individual collection in users, matches, moves, ratings. So FSDB basically your database dot collection users, matches, moves, ratings. So this ratings object has a reference to my ratings table, moves has to moves, matches to matches, users to users. And why this matters is, like, if you see their example, so what they are doing is they are using the reference of the database, just like this is our FSDB, and they are doing db.collection city. So each and every time they are going to get a reference to the collection of, well, to your tables, and then to the document. But instead of writing this, now what we can do is simply we can write users. So if I were to get a reference to 123, so let's see, copy this, let's write our code here itself. Oh my god, Logitech mouse and its double clicks. Fucking. So to get a reference to our like users table and then to our 123 user and its data, if we were to follow Firebase example, it would look like this, our code. And if we are to follow what I am doing by storing references to each collection in individual properties, we could simply do something like this. Like, I know it doesn't matter that much, but you can save a large amount of time, because you only need to remember that you are storing a reference of this here, of your users table in a users property. And so as you will see in further code, I'm just storing everything like this, I'm accessing everything like this, and it's easier to do that. So let's see, now I have reference to everything. And as our first example, what I did was we are going to add a new user to our database, and for that as you see, like in their example, yeah, their examples really suck. So what they are doing is they get a reference to the document called LA. By the way, when you do this document.la, you it means you want to create a document named whatever you supply there. So when I supply 123, it will create a document called 123. When I don't supply anything, it will use a random string to create a unique randomized document ID. And this actually doesn't really matter what's displayed here, it's only for your visual reference, because the important stuff is here, your fields in your data. This is just the name of your document, doesn't really matter, but yeah, it's good for visual reference. And generally speaking, you should be using your document name as whatever primary or unique field your data is going to be. So in my users table case, it's user ID, this is going to be unique, so I use user ID here. In my matches case, my match ID is going to be unique, so I use match ID as the name. In my moves field, I am storing moves for a particular match, so again I'm using match ID as the document name. In my ratings case, I'm storing ratings for each user in a document, so I'm using the user ID as my document name. And then what they are doing is they are creating a dictionary of their data, because Firestore is key value pair data type, uses data structure. So most of the time you will be working with a dictionary, and so dictionary should be of type string and object. Yeah, just go with string and object. So the key type is string, the value type is object, and because the value can be object, it can be string, number, and anything. And unless you specifically like typecast this object, the value you're providing, into a particular data type, Firebase will automatically detect and set its data type to whatever it thinks it is. And I'm telling this now because if you check my users table and user ID, so initially speaking, let's take this example. So initially speaking, I was providing my user ID as a numerical value when I was testing, and I knew that my user ID would include characters and letters, etc. So it should be of string type. But because when storing my data in the dictionary, I did not provide the data type of my user ID field. Firebase detected it as a number and stored it as a integer. Like you can see it's string here because I changed it manually, but initially it stored it as a number. And why it matters, like it matters very much, you will see in a bit. So we will, like, you should be typecasting this. I will show you some examples, but generally speaking, don't use this. Again, don't use their way. Create a structure of your table, of your fields, use a custom struct and set your data that way. I will show an example of how I am doing it, and I will provide a boilerplate code for it in my blog post. You can just copy paste and reuse it. So let's see what we are doing for adding a user. Now this method was originally only this much. Like, this is the actual code and how the actual method looked like for adding a user. And like what we are doing here is we are sending a user ID, which is obviously our unique and primary key, the unique ID. And then we are sending all the user data in a dictionary of type string and object. So the way to add a new entry or add a data is basically following the same example from Firebase code. Just get a reference to your database, get a reference to your collection where you want to store it, and call .document method and provide it with a whatever document name you want to use. Otherwise, if you leave this empty, inside this empty, it will use a random auto-generated document name. And so, like, I've provided some quick reference code here. So db.collection_city is basically the reference to our database, reference to our table called cities. Create a new document named newcity.id and then set async. This is the method which actually adds the data asynchronously, in other words, in background thread, and it means added data of of a dictionary type city. And so what this does is it creates document with name provided by us. If you do not do document use this document and provide an ID, you can also do something like database collection, directly add async, provide your dictionary of data, and what it will do is it will create a document using a random ID. And like, depending on your use purpose, your use case, you can just use random document IDs or you can provide your own document names. This just makes it easier to like view and analyze your data by human eye. So another thing to take note of here is if you use async set async method, it will create or overwrite any data. And this thing like add async, this won't overwrite data as always a unique ID is generated. So what this means is if we are using set async, we provided some data if this document ID does not exist, it will this code will create the document, it will add this data to that document. And if you run this code again with same document ID but different set of data, what it will do is it will find that, oh, this document exists, so we don't need to create it, we don't need to create a duplicate copy of it. Instead, it will replace the earlier data with the new data you are providing. And again, another thing of importance to note here is any fields that you provide in your second call which don't already exist in your first call will be created. So take this as an example. Suppose in our first call we sent some user data with only 3 fields: reg time, user ID, username, and this record was created. Now if we make this call again with document and provide same user ID 123 and send some new data with new fields and new data in old fields, what it will do is it not only will it override all these 3 fields with the new data we are sending, any fields which do not exist here but exist in our new data that we are sending will be created. So basically, if we were to send all these fields in that call, it will create all these fields here and fill them and override these ones. And this is important again because like it can mess things up in your code, it can mess things up in any conditional checks you are making in your code for some particular fields. And like if by mistake you provided you made a call with a document name with data that already exists and you set async, all your data will be overwritten without any warning. It won't tell you or throw any exception, oh, that this exists, do you really want to overwrite it? No, it will be overwritten. And yeah, handle this with care. Otherwise, just use add async, let all the document entries be unique, document names be unique. So even if you send same data, it won't be overwritten and it will be recreated. So as I was saying, in my users table the user ID is unique, but if I was using add async instead of set async, I will have randomly unique document IDs. So I will have duplicate records of the same user, say Royasa, and this in 2 different documents. And yeah, like again, this depends on what your use case is, how you want to handle your data or structure your data, but this is important. Now same way, there is another interesting option in set async which is called set options merge all. So what this did was it will override any data that exists, it will add any new data or fields that don't exist and override everything. What this option does is it will not what this will do is it will not overwrite any data, any fields that already exist, and only add the new data and fields. So in same example, suppose in first call we did this, in second call we sent new data, new fields with set options dot merge all. These 3 fields will not be overwritten and any new data that we sent will be merged with this one. So like this option is kind of best of both worlds. It will add new data and keep the old data as it is. So these are important methods for adding new data, and we will get about this in later videos. It is for getting the data. So yeah, let's get back here. What we are doing is we need to create a document reference to get the document of our user ID. So this is our collection reference of users table. and we are telling it that create a new document. We are going to create a new document with the supplied user ID 123 or whatever it is, and then store the reference of that newly created document in document reference. Then we are going to use the above doc reference dot set async and send the user data that we want to add to that table, the dictionary, key value pair dictionary. And because it's a asynchronous task to be run in background, we are going to create a action basically. So this code will be executed, this inside code will be executed when it finishes adding user data, it finishes the API Firebase SDK call in background. So when this finishes, whether it's success or not, this part of our code will be executed. And what we can do is so you can show a loading or progress bar here that we are about to add the user data, and once the method call completes, you can disable the loading bar or progress bar here. Then you can use the provided task to check if it completed, if it was success, if it was faulted. Just checking is faulted is good enough. If it threw any error or if there were any problems, this thing will work. So you can just make a debug log entry that user registration failed, tell us the exception and its message what happened. Or if it did not fault it, that means this is the success code, our user was registered, and we can check the reference, we can use the document reference and ID to output the newly created documents ID, which is basically what we supplied here. This is same as this, so this will output 123. And that's pretty much it for adding any data to your table, to your document. This is as easy as it gets, and let's see what kind of data we are sending in. So I've created a separate method called do testing to put all my testing code here, and I'm calling it from start method. So in my production code I can just comment it out in start, and yeah, this will be disabled. So normally speaking, when we create a dictionary of data that needs to be sent, we create key value pairs. So this is our key, and key is basically the field. So reg time, user ID, username are all fields. This is all our value that we want here, actual values. So the important thing to note here is like this. So suppose if I was doing something like actually I think I've commented it somewhere. Okay, so yeah, so let's say there are two ways to store a user ID. So there is this way and there is this way, and the difference is, although both of them look same, this will store the user ID as a string because of the quotes, Firebase will automatically detect this and store it as a string, and this will store it as an integer. And although this does not matter while storing data, it matters while retrieving data, because you cannot for this field you cannot do checks. Let me separate this. you cannot do checks like this if you're storing it as int. You need to do your if checks as int only if you're storing it as int. Same way, if you're storing it as string, you need to make all your conditional checks as string and not int. And this is important because, again, as I was explaining previously, if the data type you're storing is not the same as the data type you're trying to compare or condition around, Firebase will just like skip the execution of that particular code and all the code after it. It will not throw you any error, it will not throw null, it will not throw empty string or anything. Just boom, you won't even know what went wrong, why it went wrong, or what you can do about it. Like, it took me 2 days to realize what was happening, and like I had to restructure all my data, my records around it. And that's why what I decided was that instead of using this way of again and again creating dictionaries manually in my code and storing the data and remembering all the fields I need to create and store empty, I created custom structures of my table. So my users table, and these are all the fields that I will be needing and storing in my users table. User, and like I can force the data type that I want each field to have. So this I could have used int here, and this would be int type. I'm using string here, so this I know this would be string type. So it's user ID, username, profile pic. This I will explain in a bit. FB token, etc., etc. And I'm storing last log and registration time as objects instead of say string or timestamp, because Firebase SDK provides a very neat method which is called field let's go. Firebase SDK provides a very neat trick called field value dot server timestamp. And what this does is, instead of using the user's local time or its PC or device time and storing it and then creating unreliable timestamps in your data, because one user will have one time zone stamp, another will have another time zone stamp, or instead of like using user's time to recalculate it into a particular time zone or UTC, just forget all about that. Use this trick. What this will do is it will tell Firebase that once the data is sent to be stored, this value needs to be replaced by the Firebase or Google server's timestamp, and this way it will be uniform for all the users regardless of whether they are in Asia or America or whatever time zone. This will use the Firebase server's timestamp. And like, you cannot retrieve the value of this code in your debug log or anything, because it's kind of an server reference, you can say. So this value will be sent as it is to Firebase, and Firebase will replace it on its server level execution with actual time. And then what I have done in my structure is I have created a neat code which I'm calling toDictionary. What it does is it outputs a dictionary type of string and object, which is basically what we need for sending our data to Firebase. And in this, what I'm doing is I'm creating a user data dictionary, and I'm adding all the fields of our structure to this dictionary and returning user data. And why this is a neat trick is because when you create this structure, let's see here. So when you create this structure, FS users, new FS users, you can populate all its fields like this. So user ID, username, registration time. As you can see, this will be replaced by the server time when the data is added on Firebase level. And any fields that I have not populated here, any fields that I have not added data to, they will still be created with null values because they are part of the structure. So the moment I initialize this, all those fields are created in the structure and empty, and then I just need to populate or add data to the fields that I actually want to use at this time or fill at this time, and all the other fields will still be created even if null. And this is the database structure uniformity of like following same data following same collection structure that I was talking about. So this way I am making sure that even if I'm not adding data for a particular field, I will always have this field in my collection in my document, and I won't run into some weird code or conditional check problems. And this is our method where we were sending the user ID, device unique identifier, and we are sending our dictionary. And as you know, because this is a structure, custom structure, we cannot use it as it is because Firebase needs a dictionary of type string object. So that's why I had created this toDictionary method of this structure. So like you just populate all the fields here and you just call this method, and it will return all the fields of your structure as a dictionary. So like this is quite neat. So even if the fields that are blank here, the things which I did not populate or add data to, they will still be added to this dictionary as null values. And then our data is sent to add new user. We use the user ID to create a document name. We use our user data, and like kaboom, that's it. Our document will be created like this, and all our data will be here. I will show you its execution in a bit, but before that, before ending this video and moving on to our next topic of retrieving and getting our data from our collection documents, let's see what else I have done here, what more code I have added. So instead of like checking this particular part, which is the actual code to add data to our collection, let's see what else is going here. So now there is a thing that, as I explained above, if this data or if this user exists, and if I call this code directly as I was before, it will overwrite that user with new entries. So even if that user exists, he registered 2 months ago, and this code is executed 2 months later, it will again overwrite all his data. It will update his registration time, and yeah, this is bad. So what we needed to check if the supplied user ID, basically if that document or if that user already exists, and if he exists, then do nothing. We can maybe just move to login, and if he does, also that user is already registered, and if he doesn't exist, only and only then we will continue to create a new user. So the way we are doing is like this is not really needed because you can do this from rules. So we make sure that user ID is not blank. Then we create a query. This will be explained in more details in next video and blog post about retrieving data in queries. So we create a queries. We use the collection reference called users, and we use the method where equal to, which is basically MySQL query of equal to or like checking. So we are asking, is there any record where the user ID, the field called user ID of any document is equal to user ID? And my voice is breaking, sorry, I need some water. The important thing to note here is that when you run a query, I have not really checked if you can like run queries on the name of documents. Maybe you can, maybe you cannot. I haven't checked it. You can. So by default, where equal to, it accepts the field name and the field value to search or compare for, and it runs that query not on the name of the documents but instead the value of the documents. So when I'm sending the user ID value, it will not check if the document name is that. It will only check, it will like read all the documents and it will get all the documents where the user ID is what we have supplied. So that's why I was that's why I said that the document name doesn't really matter. It's only for our visual reference and appeasement. So if we have built our query, we want to find if there are any users which have the user ID that we want to register, and then we will call the query.getSnapshotAsync, which is basically Firebase way of getting all the documents if which match this query. Rest of the uh, task and action part is same because it's also async. All the Firebase codes are async. So this part almost remains same as adding new data. We get our task, basically the result from our execution, just like how we got the result here in task. So when we get our snapshot task, the result, now we are asking if the task ran successful. If it did not, and if it returned any error, this will be true is faulted, and we can print. I'm printing no user found, but this should be like some error occurred and the error message. And most of the times you will run into this because of the rules that you have set up for your Firestore database, and like rules are meant to be a completely separate topic. You need to read about rules. Basically it's like firewall rules which determine what can be read, what can be write, and I'm using like custom rules where I have custom permissions that allow anyone to read user collection, but write should only be possible if user ID is not null. Then I have another rule which says like allow read and write to every other collection and document. So my advice is that by default Firestore has this rule. It says match any collection or documents, and read and write is false. So the first time you run your code, your calls to Firebase SDK or Firebase engine, it will fail. And it will fail because by default the rules say do not allow anyone to read or write into our collection or into our documents. So just double click in your rules and change that false to true and publish your rules. Like just change it to this will allow everyone, well not everyone, but your app to read and write to all your collections and data. You can like create more complex and custom rules like this further on, but for now just keep your rules here so you can test your code, make data additions, and retrieve your data. So like when starting out I did not know that much about rules, and this was one of the main reasons I was running into this faulted condition where my calls were failing because Firebase was rejecting all my calls. So like yeah, I turned it to true and everything is okay. Now we are checking that in the task get the result and then get the documents. So basically all the results, documents retrieved in the results, which are individual users which match this query. And because our user ID will most probably be unique, it should be unique across our users table, this result should either be 1 or less than 1. So If it's less than 1, basically 0, it means the user does not exist, and we can proceed with registering or creating the user data to our users table. And if it is not less than 1, if it is 1, basically that means that the user is already registered, so do nothing. We will I will explain a bit more about queries and all these checks in the next part of the video and the blog post of retrieving and reading the data, querying, and maybe even explain some rules. But yeah, that's it. So rather than the code, rather than the Firebase code itself to add data, do not get into all this complex stuff of checking your data and all. Just play around and try to add some data using this kind of code. And you can also play around and try the set options dot merge all option to see how merge all works. Just send some data first, then modify your dictionary, add more data, new data, and use the merge all to see how it affects your database. And that's it to adding data. The moves table also is pretty standard. Add to ratings is also pretty standard. This is a bit more complex thing. So for ratings, what I'm doing is I'm checking if ratings for a user exist. If they don't exist, add initial ratings for that user, the provisional ratings. If they exist, get all the ratings data of the user, and in the data of the ratings that we are getting, we are gonna add additional ratings data and re-upload that modified data. We will check it out in later videos. I think the more important thing, rather than adding data to Firebase or all this code, because the code is pretty simple, let's be honest, the more important part is how you structure your data, how you use fields name, how you stay consistent across your field names, your data structure, your dictionaries that you are reading and writing, etc. So I would say just use this way: create custom struct, create your fields name, provide proper data type, create this kind of method which can output your structure into a dictionary, and you can even do some fancy stuff. So for reference, let's see match moves. The actual method of uploading match moves is pretty simple. It adds a dictionary to a table, but the real magic happens in the structure itself. So the structure has properties match id, last move by, and then we are using a dictionary. So basically we are using a sub collection inside a document, and let me show you. So this is the document name, which is the move id, last move by, match id, all string types. But the moves object is a map. Map is basically a dictionary. So you can add a field of type array, and even within array you can add a field of type map, which is dictionary, and in a dictionary you can again add an array, and you can create very complex data structures, nested data structures as per your needs. And this is the beauty of Firestore as a seed. You can visually see what you can do, you can visually see what you have done, and it's so easier to read and understand. So it took me some time and writing on paper how I wanted my moves database to be, how I wanted to store moves in order, and what fields or what values I wanted to store per move. So basically when I add moves to my moves sub object to my collections, I want to store the field made by, which is which user made this move, what move did that user made, what was the time when that move was made, and if the user who made the move was white or black. Well, if white is false, it means it's black. And this way, like, because this is indexed in numerical order from 0, 1, 2, 3, 4, 5, 6, 7, 8, 200 or whatever, I will have a perfect copy, a perfect history of how this match of chess was played, in what order of moves and all. And like, this gives me a lot of data to do a lot of stuff, whether it's calculating ratings, creating replays of the games, creating spectator mode, creating a web version of chess like how light chess does it, etc, etc. So like, this is very particular to my own use case and game, but it's just to show you how different, how complex things you can do. This is not possible in MySQL. You would have to create multiple data entries, you would have to create multiple columns, create relations, and like, this is when I tried and saw that I can do this, like, I absolutely fall in love with Firestore, and I think this alone is more than enough reason to use Firestore for all your database needs, whether it's for app or game. And another beauty is that if I'm getting this document and SSO, your object can have array can have dictionary can have another array, and like, you can create very complex long nested structures in a single document. When you get this document, you do not need to get this full document, that kind of large nested document. You can query and filter it so you only get what you want, whether it's full document with nested structures or nested to 2 levels, 3 levels, etc. So let's see again how I created this custom moves structure. So I created a dictionary called moves, and then I created a constructor of this structure called fsmoves, obviously, in which I provide the match ID. When I initialize this struct, I'm going to set the match ID, and this match ID will be set here. Last move by will be set here, and this structure initialization is not, this constructor initialization is not needed here or in most of the stuff, but it is needed whenever you want to create a field or a object of type dictionary, because you need to initialize the dictionary, and you cannot do this anywhere else, because like, when you initialize your struct and if you start adding data and this is not initialized already, you're going to run into exception errors. So, and as a more complex example, the same I have done in my ratings table. So these are all standard fields of the rating document when I create a rating for any user, and then I have a dictionary of type of which is called ratings, which will hold individual match ratings for a user. Same way I have created a constructor here, and like, unlike this, so in match moves I'm only passing match ID, I'm setting last move by manually, like a normal struct. But in the constructor of fs ratings, I have done it so that I can pass user ID, I can pass rating, RD, all the fields in a single call itself, instead of individually setting the values. And even if I do not send all these fields, they are optional fields, and by default their value will be 000 false. So yeah, this is this makes the work so much easier. Like, I can add ratings, I can add complex ratings of each match, each game in a single call now, by just initializing my struct and making the constructor call. So yeah, the more important part is you need to initialize this dictionary, create it, like, regardless of whatever you want to store in your dictionary. keep its data type as string object, the key string values object. So constructor, and then we have again created our cool method to dictionary, and again all it does is creates a dictionary object. It adds all the values of our structure into the dictionary and it returns dictionary. So all the values of our structure are returned as a dictionary, which can be passed directly to Firebase. Pretty neat. And as you can see, it adds the moves dictionary in a field called moves. So if you see here, the field is called moves. It is of type dictionary. Map is basically dictionary, and voila. And then I have also created a method called addMove. So I was trying to find ways on how to add values to this individual dictionaries. One way was to just access it using fsmatchmoves.moves.add blah blah. Instead, let's just create a simple function addMove and send all the data that we want to store as a move. So we send the move name of type string, we send the move made by, we send isWhite, and so again we create an empty dictionary called _move. We add the field move, we add the field made by, we add the field white, and as for time, we again use this quick function provided by Firebase, field value.server timestamp. So instead of the user's time when he made the move, we will know on server value when he made the move, and it will be uniform across all the users, all the games, all the matches, and like this is how it should be. And then what we do is what we have done is we have created an index so of integer type, and in this index we are just checking the count of our moves dictionary, how many moves do we already have. And why we do this is because suppose if you because we want to store all our moves. Oh yeah, so this is another thing. The field moves is of type dictionary, and this dictionary holds, you can say, sub dictionaries, where the, if you check it out, the key is 0 and then it holds another dictionary. So we have dictionaries inside dictionaries, and this is pretty neat. And because we want to store it numerically from 0 1 2 3 4 5 6 index, you can use name or whatever, we use this easy method and we check if how many objects our dictionary, how many moves our dictionary already have, add it to our index, and then in our main dictionary of moves we add a new entry index.toString, and we are adding it as string and not int, because this is end and because it's end, but we need to convert it to string because our moves dictionary has key type of string. Convert it as string, add another dictionary, add our moves data dictionary here. So when we add first move, the index will be 0 because there is no data. So at index 0, key 0, we are going to add another sub dictionary. After first move, we will have this index as 1. So at position 1, add another move. Position 2, add another move. So on, so forth. And like this is a neat trick to, well, replicate our dictionary as an array, because ideally what I was trying to do was I wanted to use this thing as an array, and inside my array I wanted to add dictionaries, but the thing is in C# you need to explicitly, like in this step you need to explicitly tell the length of your array, and since we do not know how many moves we are going to make, that wouldn't work. Another option was to use list, but instead of list I found out that like we can do this kind of stuff. We can create dictionary inside dictionary, and then fields, and this map data type that's shown here is actually of dictionary type. And uh, where was it? Google actually provided a link. Like that's the thing about their documentation, they have a link to all the data types, but it's not provided as publicly or as easily to find. I actually added it somewhere for ref. Oh yeah, it was this. So you can see here that Firestore data type is written here, and what this data type means in .NET or C#. And I found out it was dictionary. Just like array type in Firestore is not actually array in C# or Unity, it's list. So yeah, this is a great way of creating complex data structures, creating easy methods. So let's see a reference example code of how I did it. So for moves, again I initialized my structure, and because we are using a constructor I sent a match ID, and then I'm setting each individual field here. This is actually useless because we already did it in constructor. And then we are calling our add move method, and we are sending the move name, who made the move if it was white, and then we are like calling our method, the Firebase method, to add the moves data to our database. Then the player 2 is going to make a move, so we are again changing all the data. We add a new move to our moves. Before made by player 2, it is not white, it is obviously black, so false. And because our moves dictionary now already contains one entry for the move, it will automatically change the index to 1. So where is it? Basically we get this result, and like this is exactly the result of making this calls. And again, this method is same as our previous add user method, and we have this handy to dictionary method we created, so we can convert our structure to a dictionary. And voila, see, like this is as simple as it gets to add any data to your Firebase database. So again, we are going to create a document reference to our document. This is the collection reference to our moves table. This, then we tell it that we are going to create a document named with the match ID. So this is the match ID, and this is our moves data that we are passing of again type dictionary string object. And then same as add user standard call, we call docref.set async, send our data that we want to add to this document, and then this part is again executed once this process completes. In background we get the task result. We check if our task is faulted, basically everything was success or not. If it's faulted, print the error. If it's not faulted, update moves. And that's it. And like again, as I was telling this, we have I've created another more like very complex example, which is to add ratings. It is not complete yet, and it has some logic fault in how I'm handling it, so I will not discuss this here. But yeah, that's all there is it to create, and like how you can create your structures, how you can add that and all. And the next video, which is to get and retrieve the data, read our data from the database, and even query it, it's going to be pretty short because it's even more simpler. So meet you in next video.